Welcome. This is the story of how I fixed the spindle motor on my little CNC router. It's a machine I use at work, and the motor is water cooled, and the water was getting into the bearings through a leaky O-ring, and I broke it, as you'll see, and I had to take it completely to bits, so everything came out of it, and this is the story of how I fixed it. So let's get started. This is a 2.2 kilowatt, I don't know if you can see that, 2.2 kilowatt three-phase motor, spindle motor off our little CNC router, and it's like all of these little Chinese spindles, it's water cooled, so water comes in, circulates through and comes out. The problem being that it's sealed at this flange point and the other flange point at the bottom with a little tiny O-ring, and they get madly deformed, so they leak, and this one's no different. And if I take the collet nut off, that's was that an ER20 collet nut, you can probably see rust, and inside the jolly old spindle it's rusty, and it I use this a lot more these days at work, and it needs fixing, to be perfectly honest, because the bearings, although the bearings feel okay now, they won't last forever if we've got water in it. So sadly I've got to take it to bits, and to do that I don't have a pin spanner, so I've made a little pin spanner, simple, a couple of bits of bent 5mm square section, a bolt through one end, a lap joint, a half thickness lap joint, and the pins are made from these. They're hardened and ground 3mm rods, and they're quite nicely made. They come out of CD players. If you scrap an old CD player, inside the mechanism you will find these two rods, and they're quite nicely done. So I strip out anything of any old piece of equipment. I will take it to bits and save what I can. So that's where the pins come from. That was easy enough, and I've also ground up an old spanner, a thin spanner that fits the flats now on the spindle nose. So now I can theoretically break that open. However, there's thread lock in here, so I need to heat it up. That's always good for a laugh. Okay. Let's get them off. Oh. Oh. Okay, I'll have to get a hammer out. Heavyweight persuader. Did that make any difference?
I tried and tried and tried to break that free, that retaining ring, but sadly I couldn't do it with this method, so I ended up going back to the drawing board and heating it up again to break that seal with the Loctite. So here we are, heating the shaft up again, trying to break the bonds with that Loctite. Being careful not to overdo this because I don't want to cause any distortion in the shaft any more than I absolutely have to. After a few minutes of this, I managed to get it hot enough, and whilst it was still hot, I took it away from the bricks and had a little go at breaking it open.
Right, I've got it that far off, and it's now been soaking with WD-40 for a while. So hopefully, I'll see if I can get a grip on this in the soft jaws and the other vise, and take the rest of it out. Okay, let's see if we can get enough grip. I'm gonna have to put that. I didn't think I'd get enough grip somehow. No. Okay, scrub that. Right, so you have to do this yourself. Here's the setup I used. Pin spanner in the holes. I used my custom spanner to lock that in position, and then you buy these by the foot. A breaker bar on the tightening nut, there we go. So now we are more or less there. It's still pretty stiff. Whoops. I find there's not much that can stand up to the 1 metre long pry bar.
This is just a rinse and repeat to get that retaining ring off. once it was off, then I could move on and dismantle the rear cover, as you see next.
I think my best option, as you'll see when we get in here, is to continue making a tool that I started. There we go. See, there's water in there. I just felt water. Yeah. Anyway. There we go.
I think this nylon disc is the manufacturer's attempt at stopping water from getting into the main bearings. It's if there was a leak between the two flanges, this is where the water would pool, and directly underneath this disc are the main shaft and bearings.
That's the other end of the spindle. Now that cap will come off. I'm hoping that there's some square, some flats to grab hold of underneath that. Right, the battery's nearly gone in this, but let's see. So, whoops, across there, I have 17.5mm, and the holes are. I have to take that out. The holes are 3.6. Okay.
After I'd measured all the dimensions for this part, I did a little drawing so that I could go to the CNC mill and a lathe and manufacture a little part to removal tool.
Started to rough out a tool to fit in there to take that out. Now I've measured those, they're 3.5mm in diameter and 17.25. Ow! Definitely got a splinter. Ow! You can't see that. Bit of bloody metal in my finger. Anyway, so yeah, they're 17.25mm apart. So the next step is over to the mill to spot some holes. This is my setup, my embryo tool with a V-block against a fixed jaw in the vise. So now I need to, there's a little tiny hole in there. I need to find out what that diameter is, put that diameter drill in the chuck and spot the centre. 3.3mm. Ooh. Spot on. Right, so if I shove that in there, blimey, it's the first time she's ever done that. I'm resetting the computer, rebooting the computer that drives it, and it, you saw that, it spun by itself. That's an absolute no-no. God, that's bloody frightening.
Running the mill here means that your eye will take out any eccentricity that you have in the setup. So as you can see, the tool has actually very slightly got a wobble on it, but your eye will automatically deal with that.
I reckon that's pretty close. Right. A small centre drill. If we go to load the wizards, oh, let me zero that first. So I've zeroed Z. Load the wizards. Select material, I'm not worried about that. Let's go with that. And I'm going to rectangular hole pattern. Tool diameter 3mm, that's close enough. High speed steer, which it is. Number of cutting tips 2. Calculate chip load. Calculate feed and speeds. Okay, Flood is on, we're going clockwise. That looks okay to me, so continue. Right, with this button sets where your center position is, your reference, that's there. X and Y position is 0, 0, so that will use that point as the center. Width 13.75. That's actually should be, no, that's right, that is right. That is the width between the, let's put that in there. Number of holes 2, length 13.75, number of holes 2, so it's going to cut just 4 corner positions. We're not cutting a grid, we're cutting a grid off, so there's no holes in the middle, but it wouldn't make any difference here anyway. Hole depth 5mm, peck depth 0.2, rabbit height +6. That looks good to me. High speed peck drill, postcode, exit.
This is the cutting sequence for this operation, but I previously, before this, I did a dry run where the Z height was set well above the workpiece so that I could check that we were running as we should, and that way you protect your tool.
Okay. Let me just get rid of that. Right, we did spot those holes. Next up is to run that again with, this time, I'm going to put a 2.8mm drill in. Oh.
Here we are peck drilling the same cycle, but we're putting in with a 2.8mm drill, which is going to be a friction fit for the pins that we subsequently fit in these holes.
Okay, so there we are, one freshly made part.
Here we are hammering the pins in. They're a pretty tight fit. They have to be so that they don't come loose when you use the tool.
Ooh, that looks good. There we go. Let's try that in the motor. Right, here's the motor. Offer that up. Get it lined up. Oh, spot on. Absolutely spot on. Yeah, the only thing that I might do is they're all slightly, because they were cut by hand, they're all slightly different heights. So I think I might just pop that in the lathe and just take lightest of skims to get them all the same height. I'll do that. I have to take light cuts because I don't want to bend these pins. Okay, have we got, are we touching all of them yet? I think we might be. Let's
Right, here I am removing the vise off the CNC mill so that I can have space. It's only a small bed, so I need space to add the fourth axis. And here it is. It's quite a nice bit of kit. This Cazual machine actually came with a fourth axis when I bought it.
fourth axis, rotary axis on, and now I just need to test it. So if we go to 4 on here, the fourth axis, and rotate it. There we go. Now we'll pop the workpiece in and machine the hex flats. There we go. I'm not even bothered what size the hex comes out at, because in all honesty it's only got to be, I'm not aiming at anything specific, so it should be quite easy to do. So let's get the spindle on. There, coolant on.
Right, so here we go. This is cutting the hex. I did this all manually with the manual pulse generator, or MPG pendant. It's not a difficult thing to do, and to be perfectly honest, it's far easier to do this for a simple little operation like this manually than it is to actually program it to do CNC.
Yeah. Doesn't have to be particularly accurate, so spot on. That isn't particularly accurate.
Once I'd cleaned the tool up, I'd start to use it to try and get the collar off, the final piece of this collar, the final few threads of this collar off. And as you see just here, I break the blasted the retaining cap on the motor, so I had to then get that out. This is the first piece of that operation, putting the main shaft in the lathe to see if I can drill it out. Tried drilling it out with larger and larger drills, but it didn't work, so I had to go back to heating it, and luckily heating it with for a few minutes, again spinning the spindle so that I don't actually distort it any more than I absolutely have to. Once I got it up to temperature, I pushed the drill in, and you'll see the plug pop straight out.
Right, here's the slug I've just taken out. That was originally on there, so I need to remake this part, and that is, I'm going to see this on camera. Let me see. That is a 1mm pitch by 8mm. Right, so the outside diameter has got to be 21, and we're sitting at 25 there, so let's whip a bit off.
It's a bit tedious, it's a very simple part to make, but I just included this so that people could see exactly how I went about doing it.
It's not the best finish I've ever made, but that doesn't matter for this. Yep. I think I might hand polish that.
I got it down to size and I'm just giving it a little polish here. Off camera I cut the thread. It's a left hand thread. Now it's important you know that. It's a left hand thread on these things.
Got to reduce that to 8mm and then cut a thread on it. A left handed thread. Okay, off camera I cut the thread, left hand thread. I didn't do it on camera because I'm generally appalled at how I cut threads. There we go, but that does fit a treat.
Having finished the part, we're just parting it off here so that we can then drill the holes we need in the back of it so that it mates up with the tool, the removal tool that we made earlier.
There we go. Face this off a little bit, make sure it's flat, and just leave a tiny little pip in the middle so that I can locate it when I get to drill the 4 holes I need. Well, there we have it, the embryo new cap. So, left hand thread, a really crappy left hand thread, we'll keep quiet about that. Once it's in there no one will know. I just need to drill the 4 holes to replicate the one I broke. This might seem bonkers, but I'm not going to CNC this to cut these 4 holes because it's really easy for me to do manually. I've got the rotary table left over from the previous job, so all I've done is mounted it vertically. Now I've put this is an old centre drill, slocum drill, centre drill that I bust years ago, and I just ground it into a point. This is a broken end mill that I've ground into a point, so if we line the 2 up we will be in the center axis of the rotary table. So let's go there. I'm just doing this by hand. There we go. That is damn near close enough. Okay, so let's wind that up. Here we go. Whoops. Okay, so bring that down. That is pretty close. So if I now go to X, and I know that I need to be 7mm over, so I can actually see on the display, I can wind that over to 7mm. Whoops. 7mm. That should be cock on where I need to be.
So here we are again, manually doing this with the MPG, feeding the tool in by hand with the rotary control on the pulse generator. It's quite an easy thing to do. It's a really simple operation. Indexing round, plunge down, index round, plunge down. That was the last thing for machining that retaining cap. So I've cleaned all the parts and we're back at the bench ready to start reassembly.
Let's start with this. It's been degreased as much as I can possibly degrease it. So, how's this go? Oh dear. It's one thing after another with this motor. Well, would you look at that? Never seen that before in a bearing. Fallen to pieces. There we go. There's all the bearings. There we go. Alright. There we are.
So, would you believe both of these bearings came to pieces? I think it's not uncommon. They're angular contact bearings. They're relatively easy to break apart. So I took the opportunity of cleaning them down, taking the degreasing them completely, re-greasing them and reassembling them. You'll see me re-grease this first one in a second.
There we go.
So here we are reassembling the parts again. Reassembly is just clearly the reverse of taking it to pieces.
Right.
It's not difficult to do. The only thing I have done is I've sealed all of the surfaces with silicone sealant.
Is push the shaft in. There we go. Followed by the retaining ring. Okay. Right, go to the other end.
This is where the camera decided it was going to stop, so I haven't got any more footage of this bit. But all I did was add the retaining cap that we've just manufactured to the back of the shaft, put the plastic nylon washer back in position, and then screwed the whole thing together with new O-ring seals and a little bit of silicone to seal it up. Then it was reinstalled on the machine back at the factory, and we did some run-out tests. Excuse the handheld footage, I was in a hurry and I didn't have a tripod. I've reinstalled the spindle, as you can see, and we're doing a little bit of run-out testing. There is a bit of run-out on it, it's not too bad. We use this machine for cutting wood and plastics to not particularly high tolerances, so it was fine. If it was on my CNC mill for metal, it would be a different story. But all in all, I'm pretty pleased. The spindle no longer leaks. There was all the rust was cleaned up off it. It works an absolute treat, and the bearings, I have to say, after a couple of hours of use, have been absolutely superb. There's no more noise from it. It's nice and stable. It cuts absolutely as well as it ever did. So it was a worthwhile experience to do this. I would recommend, if you have a go, be careful. Getting the retaining ring off the front is really tough. I hope you've enjoyed the journey of watching me rebuild this router spindle. If you've liked it, please subscribe. If you liked it, please hit the like button. Thanks for watching. Take care. Bye-bye.